Today we're going to look at how ions or atoms form an ion. And ions are basically just atoms that have a charge. Remember that our atoms are made of protons, electrons, and neutrons. Neutrons are neutral, so they wouldn't have any effect on the charge. And protons are stuck in the nucleus, so we're not gaining or losing protons, because if we do that, we change the element. So if you gain a proton, you become the next element on the periodic table. If you lose one, you become the previous element on the periodic table. So the one thing that can be gained or lost, and we've talked about this before, is that the electrons. And the whole purpose of that is to get a full outer shell. And that's what makes an atom more stable. Gives them a stable electronic arrangement. So if you think about why electricity is dangerous around water, a lot of people think that it's actually the water that conducts electricity, but water is actually not conductive, and I'll show this in class. It's actually more about what's in the water. So if you think about tap water isn't pure. We add atoms and ions to it. So we add chloride and fluoride to it, and those ions is actually what carries the electric current. So it's the charged atoms, not the water, that are carrying electricity. And remember, current electricity is just moving charges. So if there's charges around, electricity can flow. So we call those charged atoms ions. And an atom gets a charge by having a different number of electrons than protons. In other words, it can gain electrons or lose electrons, like in the little cartoon here. The guy's been hit, he's lost an electron. The guy says, "Are you sure?" He says, "Yep, I'm positive." He's positive because he's lost his negatives, or some of his negatives. So since protons are stuck in the nucleus, we can only gain or lose electrons to fill the outer shell. And that's how atoms get a charge. Now, a negative ion, now this is where we have to think about what we're gaining and losing. If an atom gains electrons, it becomes more negative, so it becomes a negative ion. It's kind of weird to think that you're gaining something to become negative, but we're gaining negatives. So we have to think of it like that. So here's a couple of examples. So if we're going to draw some Bohr diagrams here, we're going to draw the Bohr diagram for oxygen, kind of relate this back to what we did in grade 9. So oxygen is atomic number 8, and its mass is 16. So I'll put its number is 8 and its mass is 16. So since its atomic number is 8, it will have 8 protons. Since its mass is 16, 16 take away the 8 protons is 8 neutrons. So now we have our nucleus, and I'm going to draw around the nucleus my electrons. And you're probably wondering, well, why are we bothering with Bohr diagrams? We just learned Lewis dot. Well, again, it helps us to understand more about the structure of the atom if we understand what's below. Lewis dot is kind of a short form for when we are looking at how things bond rather than drawing this whole thing out. Lewis dot will help us understand how things actually go together. So since oxygen is in column 6, it would have 6 valence electrons. I've got 6 and 2, that makes my 8. Now, how would oxygen get a full shell? Well, if we're looking at oxygen, it would like to get an electron here and here. So it probably is going to gain 2 electrons. So what ion would it form? It is going to get a -2 charge. Now when we write that ion, we actually will write the symbol, and we write it like this, 2 minus. We don't write -2. In chemistry, that actually means something a little bit different down the road. So we're always going to put the number, then the charge. So 2 minus, 1 minus, 2 plus, 3 plus. It's always going to be number and then charge. So that would be a 2 minus ion, because if I put an electron here, an electron here, if you think about it, it has 8 protons, so it's 8 positives, and it has now 10 electrons, so it has 10 negatives. So your overall charge is -2. So let's do another one. Let's do fluorine. So fluorine, again, is number 9, and its mass is 19. So drawing the nucleus now. So we have 9 protons, that's the atomic number, 10 neutrons, because if we take the protons away from the mass, it gives us what's left for neutrons. And now we're going to have 9 electrons in a normal fluorine atom. So I'm going to put 1 there, 1 there. Draw our second ring. Again, fluorine is in column 7, so it should have 7 valence electrons. 3, 4, 5, 6, 7, and 7 and 2 make 9, so I have my 9 electrons. Now, Again, if you think you have 9 electrons and 9 protons, that charge adds up to 0. That's a normal atom of fluorine. But to make it an ion, to make it more stable, it would like to get an electron there. So if it gains 1 electron, this becomes 10 electrons. So now you have 10 negatives and only 9 positives. So what ends up happening is you get a -1 charge. So we would write that fluoride ion as F minus, or you could write F1 minus. Either way is fine. Typically we'd just write the minus. It's kind of like in math. You don't write 1x if you don't have to. If there's an x, you write x. So if there's a minus, you just write minus. Now, if we want to do a positive ion, this is where we're losing electrons. So again, this seems counterintuitive. How can you lose something and become more positive? Well, you're losing negatives. Another colleague of mine called it losing bad habits. If you lose your bad habits, you become more of a positive person. So let's do a couple of examples. Lithium. So lithium is atomic number 3, and its mass rounded up is 7. So that means it has 3 protons, and 7 take away 3 is 4 neutrons. So there's our nucleus, and then in our orbits we're going to put our electrons. It should have 3 electrons. So 1, 2, first shell's full. So that means the second shell only gets 1 electron. So it looks something like this. And now, in order to fill lithium's shell, it has a couple of options. You could add in 7 electrons. So I could put like electrons here, 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 and here. But that's a lot of work. And you have to go and find 7 more electrons. So instead of doing that, I'm just going to see if I can erase what I've got here. It won't let me. There we go. So I'm going to take that out and redraw my orbit. Instead of doing that, what I would like to do, another option, is we take away, or we get rid of that electron. If we do that, I'm going to put that lose 1 electron. If we do that, if you think about what you're left, what remains afterwards, is this whole outer ring is gone. And the inner ring, because it's already full, now we have a full outer shell, and it's a more stable arrangement. So if we lose 1 electron, we would have 3 protons and 2 electrons. So our overall charge is +1. So we would write that as lithium with a positive charge, 1 plus or plus. Now beryllium, same idea. Beryllium is atomic number 4, and its mass is 9. So it has 4 protons. 9 take away 4 is 5 neutrons. Now an atom of beryllium would have 4 electrons. So I'm going to draw in my 4 electrons. 1, 2, and also beryllium's in column 2, so it should have 2 valence electrons. So 3, 4. Now same thing for beryllium. It could gain 6 more electrons. It would have to put 1 here, 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 and here. But that's a lot of work to find 6 more electrons. It's very unlikely. It's a lot easier to just get rid of this one and this one. So lithium would like to lose 2 electrons. And that means that now lithium has 4 protons, and it would only have 2 electrons. So our net charge, if you have 4 positives and 2 negatives, you have an overall charge of 2 plus. So beryllium would be a 2 plus ion. So there's a difference. Atoms and ions. Atoms are neutral, and that's what we dealt with mostly in grade 9. Ions are charged. And that's all an ion is. It's a charged atom. Now, what you're probably noticing, or hopefully you're noticing, is that the 2 that I just did were metals, and the previous 2 were nonmetals. Nonmetals are atoms that have more than 4 valence electrons, so they're more likely to gain electrons to fill their shells, whereas metals have less than 4 valence electrons, so they're more likely to lose. Whichever way is faster or easier, that's what they're going to do. So, you can gain up to 4, or you're going to lose up to 4. So let's do a couple more. So chlorine, and now I think I'm going to do these in terms of maybe Lewis dot, just because, or even just the number of valence electrons. So if we look at chlorine, because we can figure out the ion charge quite quickly, chlorine is in column 7, so it has 7 valence electrons. So it's going to gain 1 electron, so it would form Cl with a 1 minus charge. Sulfur is in column 6, so it has 6 valence electrons. So it's likely to gain 2 electrons, so it will form sulfur with a 2 minus charge. It gains 2 negatives. Now aluminum is in column number 3, so it has 3 valence electrons. And now when I say columns 6, 7, and 3, it's really 13, 16, and 17, but we're just dropping off the 10 just like we did before, and just that tells us the number of valence electrons in these groups. So with 3 valence electrons, you could, to get to 8, you could find 5 more, or we could lose 3 electrons, and that's what's likely to happen. So aluminum will always like to form a 3 plus ion because it's losing 3 negatives, it's becoming more positive. Calcium has 2 valence electrons, so it wants to, instead of gaining 6 more, it's going to lose 2 electrons and become Ca with a 2 plus charge. Again, losing negatives makes you more positive. Now nitrogen is in column 15 or 5, so it has 5 valence electrons, so it would like to, well, we could lose those 5, or we could only gain 3, so 3 electrons. That would get us to 8. So nitrogen likes to form a 3 minus charge. So this is how our atoms form different charges and end up with their full outer shells. So I'm going to ask you guys to try these ones, but we're going to change a couple of them up because we just did a couple of these. So I'm going to change calcium. We're going to change that to magnesium. And sulfur, we're going to change to phosphorus. Same idea, but just different elements, just to change this up. So give these a try, see if you can figure out the charge and how many electrons it has to lose, and write the symbol with its proper charge. Pause the video, give these a try, and then check it with my answers right away. So magnesium, an atom of magnesium would have 2 valence electrons. It's in the second column. This is why we focused on those columns and periods last year, because the column tells us the valence electrons. So we have 2 valence electrons. We could gain 6 or lose 2. So it's going to lose 2 electrons. So to form its ion, it's going to be magnesium, and since it's lost 2 negatives, it's going to become a 2 positive charge. Phosphorus is in column number where are we at here? Column number 5. So it has 5 valence electrons. So it could lose 5, but it's easier to gain 3 electrons. So now if phosphorus gains 3 electrons, then its charge would be a 3 minus charge. And then the symbol would be phosphorus, P, with a 3 negative. Now, some things for us to consider. What types of elements, I already kind of mentioned this, what kind of elements lose electrons and which ones gain? So our metals are our losers, and our nonmetals are the gainers, because where that staircase is, it's right at the cusp of where you've got 4 valence electrons. So at that point, you either could go up or down. If you get to 5, you're definitely going to want to gain. If you get down to 3, you're going to want to lose. So that's kind of the transition from metals to nonmetals. Metals like to lose their electrons, and nonmetals gain. Now, why don't atoms gain or lose protons? Because they're in the nucleus. And if they did, you would get a new element. You wouldn't have the same element anymore, because if, let's say, you took carbon, it has 6 protons. If you added a proton, it's not carbon anymore, it's actually nitrogen. So if we change the protons, we're changing the element. It can't be, you can't just change the element. That would have to be nuclear fission or fusion. That's something further on down the road. So what would happen if they gained or lost neutrons? Now, this is something we're going to look into a little bit more closely in grade 11, because this does happen. Atoms have some elements will have different numbers of neutrons, and those are called isotopes. But if you think about a neutron, the charge wouldn't change because they are neutral. So the charge doesn't change, the element doesn't change because you're not changing the protons, but because neutrons have mass, they would get heavier, so, or lighter, depending on whether they gained or lost. So mass would change. If we understand these concepts, then the idea of ions and isotopes and all of these things that we're going to be looking at this year and in future chemistry courses, if you understand that electrons are gained and lost because they're in the orbits and it makes a stable arrangement. Protons, if you change them, you change the element, and neutrons, you just change the mass if you change them. If you kind of get those ideas, what protons, electrons, and neutrons do, then you'll have a better understanding of most of the concepts we're going to be looking at in this course and in future chemistry courses.